All right, chapter 21, problem 5. We have a car with a 30-watt headlight and a 2.4 kilowatt starter connected in parallel to a 12-volt battery. The question is, if you stuck them in series instead to the 12-volt battery, what kind of power would they actually pull? What would they consume, right? And so the big thing here is we've got to figure out how much resistance each one has. Now power, right, is IV is V squared over R is I squared R, right? So the one we're going to use here, we need to know their resistance, that the resistance of each one is given by V squared divided by the power. All right, so the resistance of the light is 12 volts 12 volts squared divided by 30 watts, right? And that's going to be 12 squared divided by 30 is 4.8 ohms. All right. The resistance of the starter is 12 volts squared divided by 2.4 kilowatts. So that's 12 squared divided by 2.4 kilowatts is 2400 watts. So 0.06 ohms, right? Okay, so now we're going to connect them in series, and that means our total resistance is going to be the resistance of the light plus the resistance of the starter, right, which is going to be 4.86 ohms. And now we have power is again V squared over R, and power though is 12 volts squared divided by this 4.86 ohms. So what's the power? Equals 12 squared divided by 4.86 is 29.6 watts. So connected in parallel, right? Let's review. Connected in parallel, they're pulling 2,430 watts of power. Connected in series, they're pulling just 29.6 watts of power. Power drops because the overall resistance went up, and that is basically a bad way to try and start your car because the power being consumed in the starter is almost negligible. All right, that's it for problem 5.